Okay, so heat capacity or thermal capacity specific means the amount of heat energy required per unit mass the amount of heat energy required per unit mass to change the temperature by 1 Kelvin or 1 degree Celsius. So this is the exact definition. Okay. Now the symbol, I'll explain this in a bit, what it means. The symbol for the heat capacity is basically small c, and the SI units for this is joules per kg per Kelvin or joules per kg per degree Celsius. Okay. Now, so the formula for heat capacity is C equals to E over m delta theta. Some people like to write E with a Q, but that's the same thing because Q is also heat. It is a symbol denoted to heat energy. Okay, I'm gonna just label this so you guys know. This is heat energy. This is the mass. This is the change in temperature, and that's the specific heat capacity. All right, everybody?
Yes, sir.
Now, what you guys need to understand is that generally the heat capacity means, let's suppose if I want to heat some water in a pan, right? So there's water here, and this is the pan, and then we're heating it. So would you believe that the pan would, quickly raise its temperature before water, or would they do it at the same time? Yes, guys. What do you say?
The pan heating up first.
The pan will quickly get heated up. The reason is that pan is a conductor, hence its heat capacity is low. So it quickly raises its temperature, right? And same goes for it can be cooled faster. But water is an insulator, hence its heat capacity is higher, so it takes time to raise the temperature. Is it clear, everybody? So heat capacity basically means how much energy you need to actually bring a change of 1 degree of temperature in 1 kg of mass. Is it clear, everybody? Any
Yes,
questions
sir.
here? Okay. Now heat capacity itself is a basically you need to understand, let's do a question and see if you guys, really understand this. So let's suppose they say water of 2 kg mass is being heated through a heater of power 2000 watt for 5 minutes. Okay. If the initial temperature okay, second please. Okay. Okay, just second please. Okay, everybody's here. Fine. Okay, so is here. Fine. Okay. Okay, Zen just joined, so we can now continue. Fine. So, water of 2 kg mass is being heated through a heater of power 2000 watt for 5 minutes. If the initial temperature is 20 degrees Celsius, what will be the new temperature after 5 minutes? Okay, and they say they've also given the specific heat capacity of water is 4200 kg per joules per kg per Kelvin. Okay, is it clear, everybody? Can you please do it? Can you try this?
Yes.
Okay, good. Fine. Right. Okay, while you guys at it, I will just fetch some water. I'll be back. Everybody must do it. I want answers from everybody, okay? Whether it's wrong or right doesn't matter. Nobody's judging you. Alright, done, everyone? That's not fair. I think this was pretty simple. Okay. Hmm. Alright, should I go on, please, then? Everyone? Give me an answer. You guys are taking too much time.
So 18.1.
18.1 is the new temperature. Why? You see, it was already at 20. You heat it up. The temperature should be higher than 20. Why is it 18.1 then?
Then 21.19.
Okay, let me ask other people as well. Okay.
So is it 71.4?
Okay, let me see. So 21 and then we got 71.4. Okay, and what about the others? Zain, could you do this? Shawez, Tamoshi, Caroline, Ali are there?
So my answer was 21.
Okay. Afan? Okay, let me do this then. Soha? Okay.
So 84 degree.
84 degree. Okay, Afan. Ali, okay. Still waiting for Zain. Zain, have you done it? Soha? Zain?
No, sir.
Okay. It's alright. It's your first class.
Sir?
Yes.
I got 21.05.
Okay, I'm going to check that. Alright, now. So C is equal to E over M delta theta, right? So first of all, we know that heat capacity is 4200. The energy, basically you guys need to understand that power is energy over time. So energy would be power into time. So to find the energy first, we got to multiply 2000 watt times. Because the time was in 5 minutes, we got to convert it into seconds. So to convert 5 minutes, it's 5 times 60. So that would be, let's just put in directly. We don't really need to do calculations twice. So that would be the total energy. The mass was 2 and the change in temperature I need. Okay, so this would be exactly like divided by 2 times 4200, and now 2000 times 5 times 60 divided by 2 divided by 4200. So this is 71.4. So this is the change in temperature. So how do we find the new temperature? So basically you guys need to understand change in temperature is equal to final temperature minus the initial temperature. So basically the final temperature was, that's what we're looking for, so let's call this T. The initial temperature was 20 and the change in temperature is 71.4. So when you take 20 there, it's going to be added up there, so it is going to be 91.4 degrees Celsius. Is it clear, everybody? Right?
Yeah.
Any questions now? Anything you want to understand? Okay, so Soha, do you understand about, and what about Zain, do you understand? Shawez?
So can you explain this question again?
Yeah. So what you need to understand is that the whenever heat capacity is given to you, you need to look at the formula and see what are the things missing, right? So we got C to E over m delta theta. That's the formula.
Yes, sir.
Okay. Now we don't have the energy, but we got the power. So to find energy, we know power is energy upon time. You know this, Zen, right? So to find energy, we have to do power into time. Alright, Zen? Do you understand this?
Yeah.
So the power was 2000, but the time was 5 minutes. So we got to convert that. How do you convert minutes into seconds? You multiply by 60. Okay? So time would be 5 times 60. So that would convert this into seconds. Okay? And then what you do, this is energy. We have the heat capacity, which is 4200. The energy is 2000 times 5 times 60. The mass is given here, which is 2 kg, and we got to find the change in temperature. So when you calculate this, it comes out to be 71.4 degrees Celsius. Is it clear?
Yes, sir.
Now check this out. The change in temperature, when you find the change in temperature, of course what you do is you subtract final temperature minus the initial temperature. The change in temperature was 71.4 degrees. The final temperature is asked in the question, that what will be the new temperature, and the initial temperature, it says it is 20, so I'm going to add 20. So when you take it there, so the temperature will be equal to 71.4 plus 20, so that's going to be 90. Wait. 91.4 degree temperature will be the new temperature. Is it clear? Now in your
Yes, sir,
exam,
but,
this question is
why
4
did we-
marks. Sorry?
Why did we change 5 minutes to seconds?
Why did I do what?
Why did you change 5 minutes into seconds?
Why did I change 5 minutes into seconds? Because when you see that this is kg, that's SI unit, watt is also an SI unit, and C is also an SI unit. So basically when every other unit is SI, you got to change the minutes into seconds, which is the SI units. Do you understand? Otherwise it would be wrong. Is it clear? Shawais?
Yeah.
Alright. So I believe we will basically stop here. In the next class, we learned some of the experiments that we need to do related to this, and then when we do the worksheet, your understanding will be even more clearer. Okay? So I will see you in the next class, everybody. Have a nice day. Bye. Alright, bye.
Yes, sir.
Bye.